Hello and welcome to me, going over your answers to factoring test number 1. I'm going to go pretty fast, but feel free to pause and take a look at it and copy stuff down as you need. But I already have the answers, so I'm going to talk fast and go through these quickly. It's up to you to pause and to take it as slow as you need. Okay, so the first problem, there's 4 terms. We know to do grouping. So I group these two, find the greatest common factor is 8x squared. Group these two. I chose the greatest common factor of -7 so that the x plus 3's would be the same. Once those are the same, then I pull that out front, and my leftovers are 8x squared minus 7. Problem number 2 is a trinomial, and it's the easy kind because a is 1. So when I find things that multiply to be 5 and add up to be 6, it's 5 and 1. And because it's the easy kind, a is 1, I can go straight to my answer, x plus 5, or k plus 5, and k plus 1. Here, I always check first in every single problem, no matter what, for greatest common factor. I found 5, but this part is now a difference of 2 perfect squares. The square root of x squared is x, the square root of 4 is 2. One's positive, one's negative. So this can go one more step, x plus 2x minus 2. The fourth one is a trinomial, but it's not an easy kind because of that 2. So when I find things that multiply, I take first times the last, that adds up to the middle. Things that multiply to be -42 and add to be -1 are -7 and 6. But I can't just go straight to my answer. That wouldn't work because this isn't 1. So what I do is I replace the middle term. Instead of -1, I write -7x plus 6x. And then here's the greatest common factor is x. Here the greatest common factor is 3. They have the 2x minus 7 in common. I pull that out. X plus 3 is left over. Number 5, 4 terms. That's grouping. GCF here is 3p squared. GCF here is 7. They both have a 4p minus 7. Pull that out front. Leftovers, leftovers. This is 2 terms. I always check for a GCF, but it doesn't have one. But I know that 16x squared is a perfect square and 9 is a perfect square. So the square root here is 4x's. The square root here is 3. One of them positive, one of them negative, with a difference of 2 squares. Number 7. It's a trinomial. It's the easy kind because this is 1. So I find things that multiply to be 48 and add to be -14. That is -6, -8. Boom. Answer is done. This is a trinomial that's not as easy because of the 3. So I multiply first times the last. That adds up to the middle. 9 and 2. I replace the middle term with those. Grouping. Grouping. They have an x plus 3 in common, so that comes out front. Leftovers are 3x plus 2. This, I look for greatest common factor. It has a 3. This is not a difference of squares. Nothing I can do with that, so we're just done. That one's finished. Number 10. This is, I always check for greatest common factor first. They both have an xy I can pull out in front. And then this, whoops, this should be a 25 is left. And that is a difference of 2 perfect squares. 3x, 3x. 5y, 5y, one's positive, one's negative. The GCF comes along for the ride. This one's the greatest common factor, but first I have to, this one's the greatest common factor of x that I do first. And then it's a trinomial that's an easy kind because a is 1. Find things that multiply to be 4 and add to be -4, which are -2, -2. I put those in. I bring down my GCF. Done. This one is a trinomial and it's an easy kind. So I find things that multiply to be -32 and add to be 4, which are 8 and -4, and I put those in. But I have to be careful in this one because when I FOIL it, I want those first guys to equal x to the 6th. You can test it by FOILing and make sure it works. X to the 3rd times x to the 3rd is x to the 6th. The outers are -4x to the 3rd. The inners are positive 8x to the 3rd. And the last is -32. These combine to be 4x to the 3rd, so I get what I started with. There's nothing wrong with FOILing on every problem to make sure that you did it right. Difference of 2 perfect squares, x squared, 1, 1. But this is another difference of perfect squares because it's subtraction. So the x can be here, the 1's can be here, 1 positive, 1 negative. This one's prime, nothing I can do with that, so I just bring it down. There we are. Here we have 4 terms. X squared comes out front, -5 comes out front, 2x minus 3's are in common, the x squared minus 5 is left over. Greatest common factor here is 2x, difference of 2 perfect squares, x's and 4's, one's positive, one's negative. We're almost finished here. Trinomial, the easy kind. Multiplies to be 24, adds to be negative 11, negative 8, negative 3. Because it's the easy kind, it can go straight to my answer. Negative 8, negative 3. This has a GCF of 12. I'll pull that out first. Then I factor this trinomial. Things that multiply to be negative 2 and add it to be 1. And it's a shortcut type, so I went straight to my answer, making sure I put squareds on it so it works. And this is a difference of two perfect squares, x plus 1, x minus 1. Make sure we have all of that. Here the 200 is the greatest common factor. So we have this. This is my trinomial. Things that multiply to be 12, add up to be 7, or 4 and 3. It's a shortcut type. We can go straight to the answer. Number 19, 3 terms. GCF is 2xy. Make sure when you divide something by itself that you get 1 in the middle. There's nothing more I can do with this. We're done. And the last one, greatest common factor first, was 3. This is left over. This is a trinomial. First times last is 30. That adds up to be negative 11, or these guys. I replace the middle term with those guys. Grouping, grouping. I have an x minus 3 in common. I have a 2x minus 5 left over. I bring the 3 down and put it with my answer. Good luck.